we know we already have some people who are using herbs. We are not able to tell those who are actually whacks, those who are cheating, and those who are really doing a good job. We want to use the center, first of all, to try and persuade those people who are practicing to use our center, to have whatever they are using to be assessed so that they are also recognized as part of the system that the nation is using to take care of the health issues of our people.
Kenyatta University identifies itself as a community of scholars dedicated to generation and dissemination of knowledge and inculcation of moral values for sustainable individual and societal development. This center is one of the flagship centers of excellence here at Kenyatta University. Fits very well within the vision and mission of Kenyatta University, as well as National Development Agenda Kenya Vision 2030. It also responds to global commitments, the UN Sustainable Development Goals, and even the continental commitments, the Africa Agenda 2063.
The National Phytotherapeutics Research Center came as a result of a proposal written by Kenyatta University lecturers, where I was the lead, to the National Research Fund. The call was about the infrastructure support to institutions of higher learning and also institutions of research in this country. And the call was in the year 2016, and we got the funding in the year 2019 to establish this center. At the National Phytotherapeutics Research Center, the kind of research that goes on around here is about medicinal plants that find use in healthcare for humans, for animals, or even anything that is associated with the wellness of a human being. Phytotherapy is the use of plants for therapeutic purposes. Therapy is wellness. Therefore, at this center, we check for quality of those products. We also confirm whether they can cause more harm to a human being upon consumption. We also support a lot of research by postgraduate students, university lecturers, from not only Kenyatta University, but also other institutions in this country, including TVET, and also others from around the continent. We are hoping also to attract other researchers from all over the world.
This is the upscaling section. This is where we do mass production of our raw materials. So after the labs are assured that a certain plant material have the medicinal properties, this is where they come so that we produce them in large quantities. This is a machine that we use in distilling our essential oils. We know different plants that have medicinal properties or medicinal claims have essential oils. What we are distilling here is eucalyptus. Eucalyptus is known for treating upper respiratory conditions. This is called a reactor. This is a reactor that has an extraction chamber or an extraction basket inside here. That's where we load our materials. We are doing what we call hydrodistillation. Hydrodistillation is mixing the materials with the water so that they both boil, the water and the materials boil. Since we know the essential oils are volatile, at their boiling points, they'll vaporize. In vaporization, we get the water boils as well, so we have the steam and the vapors of the essential oils. So after boiling, the mixture of water and the essential oils will rise as steam. The steam will be condensed to get the oil and the water still as a mixture, but down here we have a separator. We all know that water and oil are not miscible. We have what we call a hydrosol collecting chamber. This is where we collect the water with some small molecules of the oil, of course. So we'll collect the hydrosol from here. It's used in the industries for manufacture of soaps. We get 3 samples for this. We take one for microbial analysis and the efficacy, another one to quality assurance to check the constituents and all that, and another one to the store. The machines that we have is a fixed oil extruder. It squeezes the oil from the nuts and the seeds. Nuts like the peanut, sunflower, we have corn, we have chia seed, we have canola seed. All those plant materials or the seeds that have oil, we are able to press using the fixed oil extruder. So what we do, we load the materials. It's pressed under high pressure, so the heat is generated. The cake comes out. That cake, we use it in animal feed, or we even consume it because it's pre-cooked already. The fixed oils extruder normally is fully commercial because it can handle 4 tons of raw materials per day. This upscaling section is very important to us here as Kenyatta University because we are developing products that will be able to sell out there to generate income.
One of the things that we do here, it's called microbial load assessment of our products. The first thing that we do here, we have to make sure that the raw materials that we receive, they don't have any contaminant with the fungi and with the bacteria. This is mostly done on the raw materials. For example, we have the peanuts that we have received. Another thing that we check from our samples, we do the antimicrobial assays. This is mostly done to make sure that the extracts that we get from the plant extract, they can be used in the humans by killing some of the microorganisms that they cause the diseases. One of the equipment that has really helped us, we have the trinocular microscope. It has really helped us because when we receive samples from outside and someone wants to check the purity of the sample, you can be able to check the purity by focusing on the microscope, and you can be able to claim that this sample is pure. It does not have other contaminants. This is what we call the adulteration of the samples. Another thing that has really helped us is the autoclave. When I'm going to take the samples from the factory, I have to autoclave my glassware. The chemical methods of using 70% alcohol, you're not very sure that it got sterilized in all the parts inside the glassware. But when using the moist heat method of sterilization, now the autoclave, you are very sure because you have the chemical methods, you have used autoclaving tape, it is indicating for sure the method was effective and your glassware is well sterilized. So it's very important to have an autoclave in the lab. Also, we have the incubator. This is where we incubate our samples. This enhances the growth of microorganisms, but without it, we can be able to get the growth on our sample even after inoculation. Also, we have the biosafety cabinet. This is very important to maintain the aseptic techniques. So it makes sure that no other microorganism is introduced on the sample, and when you are working on it, you as the user, in case there is any contaminant on the sample, it cannot harm you because of the air that is circulating on the sample. And also because of the HEPA filters on the biosafety cabinet, it ensures that no pathogens are released to the environment. So it is very much important because it protects the user, it protects the sample when you're working on it, and also it protects the environment. The importance of this microbiology section, it It's for quality control in the determination of microorganisms, to make sure that the products that are taken or consumed by our clients, they don't have any contaminants with any aflatoxins and with any bacteria that can harm them. Before we had these machines, it used to take a very long time before even you identify the plant species that is of medicinal value. And even if you identify it, it was a struggle. It was not as easy as it is now, that I can go to the garden and come with a medicinal plant that is of medicinal value and be able to give the results in a very short time. So it used to be time consuming and tiring. But with the arrival of the machine, it's something that you can do with a very short time and you'll be able to come with the results.
In the wet laboratory, that's where we do extraction, separation, and anything to do with water. The current work that is going on around here is related mainly to students' work. We have students from as far as Liberia, Kenyan students from other universities, and they are doing master and PhD level. Some of them are doing cancer research. Another one is doing diabetes research work from plants. There are quite a number of such researches going on. The machine is called a freeze dryer. Freeze dryer, in other terms, it's also referred to as a lyophilizer. The purpose of that machine is to remove water after extraction of a herbal material. It works by freezing first the sample. And when you freeze the sample to about negative 55 degrees centigrade, the water becomes solid at very low temperatures. And then after that, then you start drying that sample. The method of drying that sample is to ensure that the ice vaporizes or actually goes into the vapor phase directly. It is so important because it ensures that you don't destroy your sample. The product that comes out of lyophilization is a powder form or oily material, depending on what is the nature of the extract. Now, that particular one has very many chemical compounds, which now allow you to do a number of things. One is to identify the chemical constituents inside that, which has no water, and you can use various equipment that are inside here. So it is a much sought after equipment because of the fact that you don't want breaking down of chemical constituents inside the sample. You want them to be as natural as possible.
My name is Faya Randolph Samukai. I'm from Liberia, but I was studying my master's in Nigeria, University of Ibadan. Yeah, I'm a student of the Pan-African University of Life and Health Sciences Institute. The university is located in Ibadan, Nigeria. So I'm here doing my research after completing the coursework in Nigeria. Okay, so I chose to come here because after interacting with Prof, who is one of our lecturers on the program, and I did some other research about this place because he initially mentioned the name of the place, that this is where he works. So I decided to do some background investigation. So after finding out, and I got to realize that they have some equipment here that are not present in the university there. So that's why I chose to come here to do my research. My research is on diabetes. So I'm using plant. I want to evaluate both the root and the leaf of the plant to see their therapeutic claim. Because in the traditional system, these plants have been used to treat a variety of sicknesses, including diabetes. So now we want to verify whether they actually work against diabetes.
We have a microbiology section here that will look at all type of possible organisms that can be inside there. That's very important. The next thing, which is very critical, in fact is the most expensive, is referred to as assay, or the content. That herbal material that you have, the content, which are usually the chemicals they are in their natural constitution in the herb, are they there? So we have equipment, a lot of equipment, very expensive equipment that will establish that actually that herb contains the necessary and the needed chemical constituents. It is those aspects also that are used when we are talking about quality control or quality assurance.
My name is Martin Kinyanjui Morege. I work here at the NPRC. Basically, I do much of the chromatographic work in this section. So chromatography means separating mixtures. So once we have a product like a sample, when you do chromatography, it means you want to separate the different components in the mixture and then to detect and identify the nature of those particular molecules that are present in that particular mixture. We have the gas chromatograph mass spectrometer and the liquid chromatograph mass spectrometer. We are able to actually identify molecules on the basis of their molecular fingerprint in terms of masses. So we're able actually to tell what kind of molecule exists in a particular sample. Previously, there was no resource, so we could not actually identify what is present in these particular oils. But now, we can actually follow our production and even assure the quality of the oils that we are producing using this particular equipment. And also, we can even identify adulteration. Some people out there are working on these particular kinds of oils, and they may claim that this one is rosemary oil. But for us, we can actually be able to tell whether this oil is authentic, is from a natural source, or it is actually adulterated with other synthetic molecules.
My name is Anthony Mwangi. I'm a technician here at the National Phytotherapeutics Research Center. My work involves operations of the spectrophotometers, and also I take part in sample preparation before they come for analysis. Currently, I'm working with Fourier transform infrared, which has the latest technology of the ATR sampling technique. The product comes straight from the upscaling section, and we can be able to tell whether we have the required elements in our products and do the analysis. I also use ultraviolet stroke visible spectrophotometer, and also X-ray fluorescence for elemental analysis. For this kind of technology where there's the Fourier transform infrared, we get what we call vibrational spectrums, where we're able to identify bonding between different compounds. So by getting the spectrum, we can be able to deduce the kind of bonding that our compounds has. Once we get the knowledge, we can be able to create fingerprints for each of the different species. This kind of technology, the ATL technology, being a real-time machine, you can carry the instruments and go with it to the field and be able to get real-time data from the field. And with its internal memory, you come and now get the data, whatever you collected from the field.
When this center is completely operational, right now it's about 95% operational. We expect it to be used at a standardization center by the Ministry of Health, the Department of Traditional Medicine, and we hope to produce some of the best herbal products in this region, or at least catch up with the region.
With the National Phytotherapeutics Center, which really is a Vision 2030 project, we are seeing the university moving progressively. Of course, from a teaching university to a research university, as we move towards a self-sustaining entrepreneurial university.